Good morning, Sevens. So this is your guys' assignment today, and I've given you some tools to help you get through it. So we have a list of 6 solids here on the side, and you just have some questions to answer. But some of these questions you probably remember from last year. Some of you I didn't have last year, so it'll be interesting to see. And then some you probably don't. So what is the name of this solid? Well, this one you should definitely know. This one you should definitely know. Some of these you might have questions on, and that's totally fine. I'll show you the vocab tools I've given you and the other tools I've given you. What figure is the base of the solid? So you might have the question like, well, this one, all the sides are the same. But given something like this, like what is the base of this solid? And that's a strange question. So I've given you some vocab things for things like this. This is really mostly vocab review, but this section is here with some vocab that might be useful. In particular, in this case, we're talking bases. So bases are here. You can see prisms have multiple bases like this. Pyramids only have one base. Same thing, cylinders have multiple bases. Cones only have one base. So using those examples, I'm willing to bet you could get through this. Like what figure is the base of the solid? Those are two-dimensional figures. How many faces does it have? Again, we have vocab back here. If you're unsure about faces, a face is a flat surface on here. So you can go through and answer those questions. Here's where we really get to it. We're talking about cross sections of these things. So I put this here and it has a ton of great description, and then at the end some problems that we'll get to maybe this morning, possibly later on today. So if you read this, it really has awesome description. We look at prisms one at a time. Here's some right prisms, and they're talking about some cross sections in here, and that's really the center of things today is cross sections. So parallel to the base, we have 2 bases here. This cross section is a cut that's parallel to the base, and it makes a triangle. You can see it's congruent to those 2 bases. This one, cross section, is perpendicular to the base, and you can see that one produces a rectangle. If you look at lots of those cross sections, you will convince yourself of these 2 statements, that cross sections parallel to the bases are congruent to the base, cross sections perpendicular are rectangles of right prisms. But then we have other types of things. We have right pyramids, and we have other things that happen. Again, one single base parallel to the base, one base perpendicular to the base. Great. Right cylinders have different types of cross sections, and I'd note here we've only talked about parallel and perpendicular cross sections, but we can do other cross sections as well. And then there's cones. These exercises we'll get to later. So when you go through here, when you slice parallel to the base, I'm talking about like if the base, well, this base is here. If we slice it parallel, what do you get? If you slice perpendicular to the base, well, if we slice vertically here, what do we get? When you slice it diagonally to the base, that's like diagonally this way, what do we get? Here's an applet I've given you to play around and help you with this. So if you're looking at maybe the rectangular prism, then here you can see our cross section, a planar cross section. Here's a plane, and I can go ahead and move this. So we can move it up and down. We can rotate it and see what happens. We can rotate it the other direction and see what happens. We can move this around to get a better idea of what that cross section looks like. Great. So you should be just working through this morning, through this, filling this out. When you finish, I have one final question for this morning. Final question for this morning is using another applet. And I don't have like a worksheet for it, but I've given you this double cone, which is actually a really important object in geometry. So we will definitely talk about that when I have you guys later on. But this cone has a cross section going on. You can see our cross section here is circular, but I can move that slice. If I just move it up and down, it seems like all those cross sections are circular-ish, at least, if not perfect circles. We can go ahead and change how big the cones are, and you can see the only thing that changes is those circles get a little bigger. Here's what's interesting. We can go ahead and tilt that. We can tilt it, and then we get other types of cross sections. So now we definitely have an oval, but if I move that slice, some of those are ovals, and then we get things that are really not ovular, or they get cut off. And if I make things even stranger, I'd have to play around with it to see. Here's my question, and we'll definitely debrief this later. What are all of the different types of cross sections you can get here? So we've seen circles, definitely. We've seen ovals, definitely. We will see some other shapes. I want to know what are all the possibilities. This is one of the most well-known questions from Greek mathematics. So we're still talking math that's over 2,000 years old. But this was a really important question, especially to maybe the first really well-known woman in all of mathematics. There are lots of really wonderful women mathematicians, but Hypatia is the Greek mathematician that made these things popular. So that's what you guys are working on this morning. First of all, filling in this table and just trying to get an idea of all these different cross sections that are either parallel or perpendicular to the base, or diagonal, like perfectly diagonal. Then when you finish this, I want you looking at the double cone here using this applet and trying to come up with what are all of the different types of cross sections we can have. So you don't have to list out like all the different circles, just say that we can get a circle, and so on and so forth. What are all of them? Great. Best of luck, Sevens. Talk to you soon.